Good morning, everyone. How are you? I hope you're all doing fine. Okay, so we are now on our third day in our lesson about elasticity. And for today, we're going to talk about shear modulus. Okay, and for our objectives for today, as you know, we have finished with the first one. Demonstrate your understanding of elasticity, elastic limit, stress, strain, and ultimate strength. We have already finished that, and I hope you haven't forgotten our lesson about that. And also, we have this one: write and apply formulas for calculating Young's modulus, shear modulus, and bulk modulus. Okay, so for today's lesson, we'll be focusing on shear modulus. Okay, so we'll focus on this one for our lesson for today. And then, of course, we should be able to wait, something's wrong. Right, so you should be able to solve problems involving each of the parameters in the above objectives. Okay, so for today, you should be able to solve problems involving shear modulus. Okay, so let's start now. All right, so as you can see here, a shearing stress alters only the shape, okay, of the body or of an object, leaving the volume unchanged. For example, consider equal and opposite shearing forces F acting on the cube below. As you can see, we have here cube A, and there are two forces acting on opposite direction. Okay, can you see that? There are forces acting on opposite directions. Okay, so this one on that direction, and we have here on that direction also, right? So what we're going to do is, let's say if we're going to move that, okay, let's say if we're going to move that greater force on that area, right? For example, if we apply more force here on that direction, okay, so instead of a parallelogram, we have now this one. We're going to push on this side, okay, so that you have this distance d, and then the length here, and then it creates an angle here. Okay, it creates an angle phi. Okay, so as you can see here, we now have the shearing force F. Okay, so the F is the shearing force. It produces a shearing angle. Okay, where's that angle? Here. Okay, this angle here, it produces this angle, and the angle is the strain, and the stress is given by the same force over area as what we have before. So in here, what is changed is only the strain, meaning the effect. Okay, so if that is the case, how we're going to calculate the shear modulus? Okay, so the stress is the force per unit area, just like before, F over A. As you can see here in our formula here, stress is equals to F over A. And then also we have the strain is the angle expressed in radians. Okay, so that is, in this case, that is equivalent to phi equals d and then L. So we have here, this one is d on that direction, and then L is this length. Okay, so d L. So the shear modulus S is defined as the ratio of the stress FA to the shearing strain phi. Okay, this one is phi. Okay, so for that formula, we have this one. S is equals to F over A over phi. Okay, so of course, the units are the same. It's in Pascal. Okay, so let us try that in an example. Okay, so we have here an example. A steel stud when I say stud, it's like a small piece of metal. Okay, so this one here, this white one here. Okay, so this is a stud, a small piece of metal which is usually attached to a surface. Okay, so this is the surface and this is a metal stud. So that steel stud, which has S equals to 8.27 times 10 raised to 10 Pascal. Okay, the stress 1 centimeter in diameter projects 4 centimeters from the wall. A 36,000 Newton shearing force is applied to the end. So what is the deflection D of the stud? Okay, so we're going to solve for D, right? So first in here, what we need to do is solve first for the area. Okay, so we need to solve for the area. Okay, so how do we do that if we have the diameter as the given here? Okay, so first our formula for finding the area given the diameter is pi d squared over 4. Okay, can you see that? Maybe I need to change my pen. Let me change my pen to color yellow. Okay, and then let me erase that. How do I erase this one? Okay, so I'm going to use color yellow equals, okay, so that is pi, and then what is diameter? That's 1 centimeter. We need to convert that to meter, so that would be equivalent to 1 centimeter is equivalent to 0.01 meter. Okay, and then of course square, and then over 4, right? So our area here would be equivalent to, our area will now be equivalent to, that is, if you multiply pi, which is 3.14 times the square of 0.01 meter divided by 4, it would give us 7.85 times 10 raised to, what's that? -5 square meter. Okay, so we now have the area. Okay, and now we can solve for the S. Okay, shearing stress, what's the formula? Shearing stress, S is equals to F over A over phi, right? But what we're trying to do is to solve for D. Okay, so how do we do that? That is F over A, and we know that phi is equivalent to D over L. Okay, or that is also equivalent to F L over A D. Okay, so in that case we can now solve for D, this one, which is equivalent to F L over A S. Okay, so in solving for D, that is F, what is F? 36,000 Newton. Okay, so we write here 36,000 Newton. Okay, 36,000 Newton multiplied by L. What is L? So our L is, where is that? Here, 4 centimeters. So that's centimeter. We need to convert that to meter. So that would be equivalent to 0.04 meters. Okay, over area is, we have here our area, that is 7.85 times 10 raised to -5 square meter multiplied by S. Okay, what is our S here? This stress. That is 8.27 times 10 raised to 10 Pascal. Okay, so we multiply 36,000 by 0.04 meters, and then we divided by this one here. So D would be equivalent to 0.22 millimeters. Okay, so you can try that in meters first, and then we could go back to millimeters. Okay, so try in meter. Can you do that in meter, and then convert that to millimeter and see if we will have the same answer? Okay, so that is how you solve for shear modulus. Right, so for today's quiz, let us try solving this one. Okay, so let us try solving number 1. Calculate the shear modulus of a body that experienced a stress of 5 times 10 raised to 4 Newton per square meter and a strain of 4 times 10 raised to 2. Okay, so as you can see, strain has no unit. Okay, and for number 2, a cylindrical bar of width 10 millimeter is stretched from its original length to 10 millimeter using a force of 100 Newton. What is the shear modulus of the system? Okay, so after you finish answering, please share your answer in the chat box below and see who will get the correct answer. Right, so that's all for today. I hope you learned something from this lesson, and then I will see you on the next video. Thank you.